Good morning. I'm Van Rogerson, president of NC East Alliance. Thank you for joining us today for our Smart Ag Emerging Technologies webinar. I'm going to cut my video off. I'm having connection problems. I'm doing it remote from where we've got some middle school teachers actually in the other room doing a little training with them. So hang on. So I want to start by just thanking our sponsors, Platinum, ECU, Integrated Financial Holding, Vidant, Kilpatrick Townsend, our gold sponsors, Bull & Company, Dominion, our silver sponsors, Port of Virginia, Evolve, Martin County, Nutrien, Edenton-Chowan Partnership, Martin Marietta, and PNC. These are the guys that help pay us to do our webinar series. So thank you to those guys. I also want to thank our presentation partners today. That's NC State University, University of Mount Olive, and also NERSBA, a new partner of ours, the Northeast Regional School for Biotechnology and Agri-Science. And Hal Davis, will you tell us just a little bit about your school?
Yes, sir. My name is Hal Davis. I'm the Executive Director of the Northeast Regional School of Biotechnology and Agri-Science in Janesville, North Carolina. Our school, the idea for NERSBA got cranked up in 1996 when the Charter School Initiative came on the scene in North Carolina. A good friend of mine, Mr. Benji Forrest, we were on the way down to White Lake to do a presentation for a group of ag teachers. We said, why don't we form our own agricultural charter school? And the rest is history. We opened our doors in 2012. We were formerly located at the Tidewater Research Station in Roper. Due to enrollment growth, it was necessary to move our school from that facility to where we're at now, which we actually own the site, the former site of Janesville High School and Janesville Middle School. We've been very successful with our student body in terms of students going on to continue, and particularly first generation college families, moving on to completing undergraduate and graduate and professional degrees. We've also had a lot of success with students going on to take on trade and industry classes and careers. One of our biggest success stories is students graduating from NERSBA on Saturday morning and going to a career on Monday morning. That's the big focal point of where we're going. We're very fortunate to be partnering with the University of Mount Olive. We have some of our former students tomorrow and some of our current students tomorrow under leadership of Dr. Sandy Maddox, who will be receiving their associate's degree from the University of Mount Olive and undergraduate degrees from the University of Mount Olive. And we certainly appreciate UMO being a part of our scholastic community. And of course, we've also had students to go and take classes through NC State University. So in terms of our school, we try to get students to appreciate agriculture and agribusiness and biotechnology, trying to get students to look ahead to those careers, those emerging careers in those program areas. And we, again, would just like to say thank you to NC East Alliance for allowing us to come on and work with you in a very collaborative basis.
Thank you, Hal. Really glad for you to be here and appreciate your partnership. NERSBA serves a great purpose in Eastern North Carolina. I'm going to move on, as always, and run through the Zoom webinar tools and agenda for today. So today will be a panelist discussion with our speakers. So if you have any questions today, please type them in that Q&A box in the bottom left. If you have a question that would like to ask live, you can click that raise hand icon in the bottom right and ask it live. The chat box will also be available. Please keep a lookout for any helpful resources or links from the speakers that we may post in the chat box. You can also submit your question or comments in the chat box if you'd like to. At any point you need to adjust your audio settings today, you can do so by clicking that audio setting tab in the bottom left and adjust your settings as needed. If you need to adjust your viewing options, you can click that viewing options tab in the upper middle and adjust your options if needed. If you need to enter and exit full screen mode, you can do so by clicking those 4 arrows in the top right. And now I'm going to turn it back over to Van, who's going to moderate our panel today.
Thank you, Ray. I'm going to do a real quick introduction of our panelists. They all have extensive bios, so I'm just going to pick and choose a few things from each one of them. I'm going to start with Dr. Gary Robertson, who went to high school with me, actually. Good friend from long ago. Dr. Robertson currently teaches undergrad and graduate level in precision agriculture technology, GIS applications in agriculture, and agriculture, environmental health and safety. Co-teaches introductory geomatics, with expertise in GPS and GNSS technology. His current extension program focuses on agricultural machinery systems, machinery management, precision ag, and Dr. Robertson has a PhD in biological and agricultural engineering. NC State, all of these are tied in some manner back to NC State. Dr. Jason Ward received his BS and master's.
Van, we lost you. I'm going to go ahead, Van, if you can hear me, and I'm going to introduce Jason and Sandy. So Dr. Jason Ward earned his bachelor's and master's degrees in biosystems and agricultural engineering from the University of Kentucky. He completed his PhD in biological engineering at Mississippi State University. He is currently an assistant professor and extension specialist at North Carolina State. He also leads the Advanced Ag Lab, which works at the intersection of farming and technology. Glad to have Dr. Jason Ward here. And our other panelist is Dr. Sandy Maddox from the University of Mount Olive. Dr. Maddox's career in the field of agriculture spans more than 44 years, having served 30 years in public service, employed by both NC State University and the North Carolina Department of Agriculture and Consumer Services. She worked in the Soil and Science Department at NC State as an agricultural research technician, was a horticultural agent and county extension director for Cooperative Extension in Pender County, served as superintendent of the horticultural crops research station in Sampson County, and lastly served as the director of division and research stations with NCDA and CS, retiring from state service in 2007. That same year, Dr. Maddox joined the University of Mount Olive as faculty member and director of the Lois G. Britt Agribusiness Center. Dr. Maddox currently serves as the founding dean for the School of Agriculture and Biological Science at the University of Mount Olive. Dr. Maddox earned a Bachelor of Science degree in conservation, a Master of Science in soil science, and a doctorate in adult and community college education from NC State University. Van, if we got your connection back, I'll turn it back over to you.
Oh, it is not. You carry on, Trey. So I'm going to have a series of questions. I'm going to start off with you, with Dr. Robertson, Dr. Ward. I'm going to call you Gary and Jason. Sorry for the informal nature here. Can you hear me, Trey?
Yes, I can hear you.
Okay. I'll start off then. What kind of autonomous systems operate now in Eastern North Carolina? Gary, start with you.
Well, some of the examples that come to mind immediately would be automatic steering and tractors and combines. Even though we do have an operator in the cab, once that operator hits the engage button, that system is totally on its own. It guides itself through GNSS or GPS positioning signals, and of course some other limitations that the operator can place. We use a lot of UAVs for crop scouting, flying drones over fields, and to ensure data integrity, we fly those autonomously. Our pilots launch them, and once they're in the air, again, they are flying on their own. They're using their own onboard sensors to maintain a uniform pattern across the field so we don't miss any data. And we also see some autonomous irrigation systems in use in various areas as well, where it can sense the soil moisture levels and determine on the fly literally how much additional water it needs to add to the field. Jason, you have anything you'd like to add to that?
No, I think this will also come up as we talk through the rest of the questions we'll be addressing on the panel. But it really kind of requires us to think about what the definition of autonomy, means, and how we're applying that. There's some really great technologies such as individual row shutoffs, that can turn off sprayers or planting in at the single row level so that you don't overspray or underspray or plant where you've already planted. And those are all commercial technologies that don't require you to throw a switch manually, right? So if we're talking about steering a vehicle, Gary has already lined out that, frankly, self-driving tractors have been around for 20 years now.
Mhm.
So when we talk about, the advent of the self-driving car, like it's something new and magical, it's pretty cool, but, we've been doing this for 2 decades, right? So, if we talk about, moving vehicles around, then yeah, we've got the self-driving machines that have been around for a while, but we also have the ability to control them at a very fine level that is reactive to the settings that we put in the machines. So, I think that's one of the ways we can define autonomy as well. And I'm sure we'll dive further into what that means here in a minute, but like that's a great way you set that up.
Okay, moving along then, Dr. Maddox, Sandy. So what's coming soon? What are the emerging technologies? What are the potential long-term solutions for farmers that you all are seeing? Sandy, you need your mic off on.
That always helps. Thank you, Van. I guess as I think about that, I think about what are some of the issues that we are facing now and are going to continue to face that we're going to have to overcome, and how can we use technology to do that? I look at labor efficiencies as a major issue. And, right now we're struggling with that in so many areas of agriculture. I know that Jason and Gary both are working on some things that are going to be tailored to try and improve efficiencies in our labor force, as it may be. Whether it's, I know one of the things that a colleague is working on at NC State is robotics for weed management or harvesting, those types of things. I believe Dr. Young is maybe working with you, Jason, to look at how can we really use robotics in agriculture and use them for the kinds of jobs that we find are more and more difficult to get people to do. I think robotics is something that's going to really be a push. I'm sure there's a lot of information that still has to come on that, but I would think that would be one, and that's being forced, as I said, by our labor issues. I think another one is, again, the UAVs. Right now we're using them for crop scouting and surveying damage and different things, and some crop health and many opportunities in agriculture. But I think we're just scratching the surface on that for our UAVs. I think in speaking with some folks involved at the corporate level for agricultural equipment, they're very interested in using smaller pieces of equipment and doing much more with them. And I think, drones are being used to spray now. I think that's going to become a more common technology or a more common use in the future. How can we use smaller pieces of equipment to do the things that we're doing now for not only efficiency, but also for environmental sustainability? And then finally, I think one of our biggest challenges may be data management. I mean, we're able to produce a world of data across the board. And I think just determining how we manage that data, I think that's going to be a technology that how do we make the data we have, how do we turn data into decisions at the agronomic level, at the farm level? I think for me, those are the three areas that I think we would be looking at, and I'm sure Gary and Jason can add a long list to those, but for me, those are the top three that I think we're going to have to look at emerging and finding potential long-term solutions for issues.
Anybody else?
Well, one technology that's starting to creep into agriculture now is the concept of a digital twin.
Mhm. Yeah.
And the digital twin is where we create an electronic duplicate of a real world environment. For example, if we collect enough data about a field in every aspect of that field, the soil types, the topography, fertility, rainfall patterns, climate data and such, we can create a digital twin, and we can use that to predict even better what varieties are going to be better suited for that field, what crops are going to be better suited for that field, what inputs are going to be needed, and particularly what time of the season does that input need to be made for maximum efficiency. So that's something that looks very, very promising, I think, coming down the pipe.
And just to kind of build on that, and I'm sure we'll wind up talking about AI here in just a step longer, but that idea of a digital twin actually becomes really important. Let's say if you're trying to create a computer vision model, where a camera can see an animal and then detect whether it's standing, lying, eating, what behavior is. So there's actually been cases now where people have made an animal inside like a video game engine and had it have those behaviors, standing, sitting, walking, whatever that is. And then we're able to train an AI computer vision model to then detect that animal's behavior in the real world. So the hard part of creating those models in the past have been training them with real targets. But if we can leverage this idea of creating essentially a digital model of an animal that has behaviors, that makes it very easy for us to train artificial intelligence and vision systems to be able to detect those behaviors even in the real world. And that's been shown to work. So I think it kind of flattens our curve on what we can do by fixing the first bottleneck, which is getting the data to train these models that we need to apply.
Awesome. We've got a question, but why don't we save those to the end, okay? If everybody's okay with that. So, Dr. Ward, Jason, so many of our farm locations do not have a cell phone signal. Can autonomous systems, autonomous equipment work there? And if so, how?
Well, I think you're asking an essential question because a lot of these solutions, whether we're talking about guidance or even some of these newer analytical tools that we can use to help make kind of bridge the gap that Sandy brought up about data to decision, they're essentially assuming that you have high bandwidth internet access to be able to move data from the farm to a decision maker and then back. So I think that it becomes absolutely essential that we start kind of crossing this digital divide. And here lately we've heard the words a lot about digital equity, and I think that absolutely applies to the urban and rural interface, right? Like we have to make sure that people in rural communities have good access to high-speed internet and make sure that it's well maintained and affordable. So what are some of the options? Well, I had the opportunity just last summer to work with a fantastic group of people. That was a project actually led out of UNC. It was Nicholas Dido, who's from the Keenan Flagler College of Business. Jessica Zufalo, who works with the FCC in Washington, D.C. And we have Jack McNary, who is at Harvey Farms. And we were able to put together essentially a demonstration of what's called CBRS, Citizens Band Radio Service. And so if you can get hardline internet to a single point, you can put up what is essentially a private cell phone data tower. And then if you have devices that need access to data, you can use essentially an off-the-shelf modem with a SIM card that's connected to that radio base, and then that you can basically create a private cell phone data network in this new CBRS band that became available from recent federal legislation. So it's an interesting technology and doesn't always have to be hard licensed. But it's probably a good idea if that's something you want to pursue, to definitely look at how you secure that bandwidth and that license. But right now it's pretty open. And so that's something that you can put up on. Now, I'm not saying it's free, right? There's cost associated with that. But it is one way that we can bridge the internet to mobile divide that does allow us to create essentially a private cell phone data network on the farm. And we were able to demonstrate that successfully just outside of Kinston. So there's a really neat way to see what the options are and how we can mobilize that data on the farm. But you're getting to the core of a very big issue of how we move that data. And being able to support local cell phone providers or local data services that maybe are willing to make the investment in these rural communities because this is where they want to live and where they want to do business, I think becomes really important as well.
Yeah, and you bring up a good point, Jason. We have a farm, a student farm in Duplin County, and about 7 miles out of Mount Olive, and put in a classroom out there and all that, and had no way to get internet service, Wi-Fi. We ended up having to put up our own tower through broadband, which was not cheap. And then, receiving signal from Mount Olive, we were within the range that we could do it. I think it's a 5-mile range. And that's, when you think about some of these pockets in Eastern North Carolina, and we're only a few miles from Goldsboro and Kenansville. And that is a huge challenge. Of course, we put up the tower, and then certain other farmers and businesses out in our area started putting up smaller towers, and the broadband was bouncing. So you can do it as a community effort, but at the same time, the cost is really prohibitive unless you have that opportunity to have maybe a lead tower there. And we were able to provide that. And like I said, it's over and over we find ourselves in that situation. So you make a good point. And I was looking at some work done, a survey, I think in 2020 with the Department of Information Technology and Broadband in North Carolina and NC State. And, 78% of farmers in the United States do not have a choice of internet service providers. So this is a huge problem. I don't have the answer, of course, but you make a good point. It is going to limit what we're able to do, I think, until that's resolved.
And going forward, maybe the new Starlink system, that SpaceX is putting up could become a viable solution. I don't know the pricing structure on that, but it's the first high-speed satellite-based internet service I've seen that actually delivers meaningful bandwidth. So we'll see what happens as the number of users increases, but it does seem like it could be a viable option going forward.
So when you guys started off and you said the tractor pulls into the field, you push a button and then it takes over, is that GPS system, does it operate regardless of whether you have a cell phone signal?
GPS is autonomous, and it is a satellite broadcast, and coverage is pretty much universal. However, autonomous GPS does not by itself deliver the accuracy that you would need for a tractor or combine to operate in the field. For that, we've got to have some source of correction. And the most common source of correction is RTK. And in the field, RTK requires a cell phone link, unless you're close enough to a dealership that's offering an RTK signal through one of their broadcast towers, or you choose to put up your own. And some farmers do that. They'll purchase a duplicate system and create a base station, so they provide their own data signal. There is another correction becoming available. It's called precise point positioning. It's not quite as accurate as RTK, but it is based on satellite delivered data or predictions of atmospheric and tropospheric phenomenon and such as that, as well as the satellite paths. Again, not quite as accurate as RTK, but it is gaining ground fast. And because that's satellite broadcast, that will also hopefully overcome some of the limitations that we have with local cell phone service and local internet service.
Okay, cool. So Gary, I'll start with you on this next one. Discuss with us all of the sources of data that is becoming available for a farmer. What can they get off of a satellite now? What do they get off of drones? Obviously, they do soil samples. They have yields across the field. I mean, there's all kinds of things I think I know, but I probably don't. So can you kind of explain what kind of data is being accumulated now? And obviously, we're talking about some in the future that's even more robust.
If you're familiar with the term big data, agriculture is right in the middle of it. And big data is defined as a data set that has variety, volume, veracity, and variability. Well, agriculture meets all of those criteria. So agriculture is definitely big data. You mentioned soil samples. We download data, of course, from NCDA lab and other private labs. It is geospatial data, is spatially oriented. We know exactly where those samples came from if we got in the field and collect that data accordingly. We do get a lot of data off satellites. There are a number of satellite constellations available that do that. Some of them provide the data. If you've got the technical expertise to tap into it, some of them post the data for free. And then there's other operators that turn around and offer you that data specific to your farm or field for a fee. So, but again, it is data that's being generated by either European Space Agency or NASA or NOAA or something like that. We can add to that yield data. A lot of harvesting machines have yield monitors on them now. And if you couple a yield monitor with a GPS receiver, you get a real good map of what's going on in that field. You see variability all over that field, and you can answer questions about how well did management work, or what's lacking in this field. Where are my good production areas and where are the poor production areas? I participate in a lot of farm management information services online. Every day I get emails from the various services with crop health images showing me what the vegetation in that field looks like the day before. And it gives me recommendations on what, if any, scouting I may need to be doing. So we get a lot of that. UAVs, we can capture a ton of data with UAVs, and it's very, very high resolution data. We're capturing imagery that's looking down at 2 inches per pixel, which means we're literally looking at the leaf level for the plant. We're not just looking at acres, we're looking at square inches to try to discern leaf level. We can do stand counts, crop health, crop productivity, all kinds of data is coming out of that stream. We have access to maps of soil types all over the country, and in some cases, even more detailed maps of soil types. A couple of fields I work on in Goldsboro, for example, we've got soil types in that field based on a detailed soil survey that aren't supposed to exist in the coastal plain of eastern North Carolina, but yet they're there. So that's another management issue we've got to deal with. We mentioned automatic steering earlier. All of that is based on the guideline. You tell the tractor where you want it to go. So that data is another layer that's being added. The boundaries of the fields are being added. Most of our spray and spreading systems and even planting systems now, if they are so equipped, will capture a map of what you've put on the ground. So you know exactly what the plant population was, you know exactly what variety was planted, you know exactly the volume of lime and fertilizer that have been applied, herbicides, other pesticides, anything that the farmer chooses to put on the ground, even in some cases irrigation water. You've got a map of that. So you know exactly what went into that. And all that feeds back into that digital twin model we talked about earlier. Prescription maps. What do you want to put on the ground? That kind of data is available. And again, we keep a wide range of production records at the farmer's fingertips, literally, so they can look back and see what's going on. And hopefully all of this turns into a profitability map. So the farmer knows exactly what part of a field or farm is being profitable and what's not, and can make decisions there to enhance profitability. So that's a few of the things that come to mind.
Wow. Anybody else? That's extensive. Well, I'm gonna move on then to the next question, which really fits right on top of what you just was discussing. So Jason, I'll go over to you. So who manages all this data, and do most farmers actually make decisions based on this? Does Extension provide some of this data to help them make their decisions, or are we moved to a world that you got to buy a service and have an expert help you with analyzing this data? Or can you have some young guy that just graduated from NC State or University of Mount Olive and, they do it for you? Give me some guidance here, Dr. Ward.
Well, much like most things, the answer is it depends. So, given the volume and types of data that Gary just laid out that are available to most people, farmers choose to farm as much about the lifestyle decision of it as much as the business decision of it. So if you want to farm, you probably don't want to spend a lot of your time in front of a computer screen crunching data, right? So if you're into the doing part of it, and I'm not saying all many farmers may be into it. They may enjoy analyzing that data, and some of them may not. So it's really going to depend on the individual farmers, interest level and proclivity, and are they a little bit nerdy or not, right? Or do they just want to drive big iron around in the field in a circle? So it really just kind of depends on their interest level. But really what we see is a lot of consultants kind of helping to cross that bridge between data collection and help getting it into a digestible form that they then offer the farmer a few options to make decisions based on the information, and then let the farmer make the final decisions. Or if it's somebody that the farmer has worked with for a while and they trust, they may authorize the consultant or the service provider to just go ahead and move forward. So I think absolutely the role of a consultant becomes really important as we move into this data-driven agricultural generation. I can tell you that I get the opportunity to work with a lot of ag economists, and if we look back historically, what we're seeing now is multi-generational farms have been the most profitable. And I think where that comes from is a deep understanding of the land that comes from long-term experience with the land, and then connecting that to leveraging the technologies that are available to them. And then whenever you put those two things together, a deep understanding of the land and why we do things a certain way in a farm, and also the technology tools where we can use to disrupt that historical practice where it needs to be changed, or to leave it alone if it's working, right? Then I think that if we can create that dynamic of a young tech savvy farmer with a partner who has been there a while and understands the decisions that were made and why they were made, that really becomes the magic bullet that creates more profitability inside the farm gate. And so I get really excited whenever I talk to our students who say, hey, I get to go back and farm with my grandfather, and I'm like, wow. So if you're leaving here with these tech tools under your belt and you get to go back and still farm, then you are creating the right mix to be profitable in that business. But I really do believe that it is going to be a combination of consultants, younger people coming back to the farm or starting their own farm. What we see is that young farmers rely on technology because of that maybe lack of experience, to help them make decisions. And so that's when we see some people maybe get caught up in these analytical tools that were made by somebody that doesn't have a lot of ag experience. They try to just start a venture capital company and say, hey, look at all this great data analysis that we can do. But really all they're doing is packaging publicly available data and putting it into a dashboard and selling it to you. So we kind of need to avoid those things. But there are some tools out there that are really good and useful. So Consults become really important, and multi-generational understanding becomes important, and knowing when and where we should invest in digital tools. And just that warning that we always hear, that if you are not buying the product, you are the product. So if you're not paying for a service in the precision ag space, then the information that you're putting into that service becomes valuable to somebody else, and it will be sold. So I guess it depends is the answer.
That's awesome. I guess I'll move on. So, Dr. Maddox, Sandy, we've talked about this some, but I'll mention this again. We all hear about blockchain. We all hear about artificial intelligence, how we're moving into new way of thinking. I know you mentioned that with the digital twin and that sort of thing, but how soon are we currently, and how soon will we see it as a routine thing that drives farmers' decisions? I'm connected to enough farmers that I know Roundup Ready's 3 times is more expensive than it was, and you can probably only get 30% of what you got last year. So I hear farmers are going down and buying disc blades because they're moving away from no-till because they can't afford all of a sudden Roundup Ready, or either you got crop varieties of corn or whatever you may not even be able to get, even though that's the one you want. And so there's so many scenarios. Or is it going to be a drought season, hurricane season, whatever? What are we seeing now? Price of nitrogen, everything's a Wild West show, it seems like. How much of this new technologies, this AI or blockchain, are we able to use yet? Thoughts?
I think we're moving forward with it. I think the opportunities are, I don't know that we've even touched those. And again, I'm not going to pretend to know Gary and Jason's knowledge in this area, so I'll defer to them, because to even explain blockchain technology and its use in agriculture, it is coming to bear, but a lot of people don't even know what that is yet. And knowing that it is a data structure that's basically proposed to save and share instantly data, and then do it in a secure manner, as I understand it. And I'll defer to Jason and Gary, but I think a lot of it is being maybe used to look at agricultural supply chain management, more so in what I know about it than maybe in production agriculture, because it's it improves efficiency, it improves transparency, it trust, all of the things, and it allows all the people that are involved in, let's say, a supply chain of a food product or food or those types of things. It gives everyone that's involved in the process access to the information at the same time. It can do so securely, it can do so almost instantly, and it just, that's the way I have been introduced to blockchain. Jerry and Jason, y'all speak to it more so than I can. That's from a very layman's perspective, though, and I know that it is as sure as artificial intelligence. They're coming together, and along with the Internet of Things, and I think there's an opportunity for unlimited growth. But Gary and Jason, y'all speak to it better than I can, I'm sure.
I think Sandy is absolutely on target with her description of blockchain. It is a data store. It is a method of providing data securely and making it available and accessible to a wide range of users. And unlike a central data repository, for example, let's say that you have all of your, I could use the example of money, but I will not necessarily go that route. You have all of your information stored in one location, and that location is sitting somewhere in a vault on the internet, and all around you there are several players that are trying to hack into it. Well, once they penetrate that one block, that one location, your data is exposed and it can be exploited. Blockchain defeats that because as soon as the data is stored in a block, the block is shared and duplicated, and you would have to simultaneously hack many locations to be able to retrieve that data inappropriately. So it is a fascinating technology, and I don't understand how it works in its entirety, but it is one of the tools that will be used to keep data secure as we go forward. Blockchain is what Bitcoin is based on. That's what digital currencies or cryptocurrencies, as they're called, are based on. It's because it doesn't rely on that central bank to support it. It is distributed across the network. So, Jason, I would defer to you at this point.
I mean, the place where we see blockchain showing up, and I agree, Sandy, the most is it's in kind of the value chain. And, you know, for me, like we've been doing some interesting work with Cotton Incorporated where, you know, we could theoretically, you know, take a bulk of garments and being able to track those back to the 2 or 3 acres of a cotton field where that cotton was harvested from. So it becomes really important then whenever we have that level of traceability, if there are receipts, somebody is going to follow them. So we always only talk about traceability from the value it creates. And I think, you know, as somebody who likes to support, you know, ag in North Carolina, you know, I would pay an extra little bit to say, hey, my t-shirt came from North Carolina. You know, I would spend that money. But to have that advantage, we also then could possibly see a record of, well, you claimed that XYZ product was not applied on this, but we can see now from your records that that was applied. Or we used some sustainable practice, and then you could validate that and say, hey, we did do this sustainable practice. So that means that this could be, you know, this cotton could be worth more in the marketplace than it would be otherwise. Right. So there's goods and bad. So if there are receipts, and if this is in a public ledger that anybody can access and see data that moves, you know, that would be tied to a commodity or a product, you better be doing what you said you were doing, because if there are receipts, somebody will follow them. So basically that's, you know, when I think about the blockchain component, that's what I think about, is being able to have traceability and have that be in a public record, and to be able to say this product can be shown to come from this field, and we have these records to prove it met the definition of sustainability as we make it as a company or industry. And, you know, would want to be able to put that on the marketing material for this. So, you know, that's kind of an interesting application, I think, but you have to, with transparency, there are consequences always. So.
Okay, moving along then. Good job. Gary, I'm going to jump back to you. Describe some jobs on the farm or supporting the farm that we can just get an idea of what opportunities are there. You've talked about a lot of these different technologies. Can you just chat just a few off the top of your head?
Yep.
Both from the farm perspective and then the equipment dealers and drones and all of that.
Well, from the farm perspective, I have several students in my class that tell me, and we chat during the academic year, but they tell me that during the summer, they've got an internship working with a farm chemical company, going out scouting fields, helping deliver products to farmers, working with farmers to make sure to get the right products. I'm seeing a lot of students now come in and tell me, oh, I work for so-and-so farms. Some of the larger farms around the state, for example, hire staff to help manage their production practices and everything. And we've got a lot of students now that they may not have grown up on the farm, but they come from a rural area and they had an opportunity to get linked up with that larger farm and go to work there, either on a full-time or part-time basis, depending on what it is. We see a lot of, on the sports side of things, a lot of service technicians. Every agricultural dealership needs service technicians, and they need people that understand what the technology is. They understand how the technology works. Modern agricultural machinery is a lot more complex than it was 20 years ago or 30 or 40 or 50 years ago. And there's a lot of information, a lot of data that's being generated just on a farm machine. And Jason can certainly speak to that a little bit more thoroughly than I can. Most of the farm equipment dealerships around the state now have a precision technology specialist, somebody that knows how the advanced systems work and can help individual farmers adopt the technology and troubleshoot problems. We can remote into a piece of machinery in the field and help a farmer solve a problem sometimes. UAVs, we talk about gathering data, but just collecting the data with the UAV is only on the tip of the iceberg. We've got to turn that data into information that the farmer can use and manage. And that means somebody's got to take all those images, have them stitched together, operate the software, drive the software to stitch them together, and turn them into the vegetation index or the mosaic index or whatever we're looking at to try to interpret that information. So there's a lot of newer opportunities coming along. We talk about automation. Once we start putting automated tractors on the farm, you're going to have to have an automated service technician available at the dealership to come out and troubleshoot anytime something goes wrong. So yes, every new step forward always brings along its need and demand for people to support it. So,
Any other thoughts?
Yeah, I just want to kind of reinforce that idea a little bit. For all the amazing things that we can do with technology in agriculture now, all of those systems at some point are ultimately dependent on mechanical systems that, even though we're hanging all these additional electric drives and sensors and everything on them, don't look that different from what they have for a long time, right? A planter is fundamentally a planter, whether or not it's got precision planting and electric drives on it or not, right? So, that still has to be mounted to a toolbar and it still has to be pulled through a field. If we're putting out fertilizer that's spread, that spinner system looks much the same as it has for a long time. So we're in a transitional phase right now where that technician, at a dealership or somebody at a farm, they need to be both a wrench turner and a button pusher. And so we need to be okay with that for a while. Even if we look at, let's say, like diesel mechanics, right, who have had to go through the tier 3, tier 4 change here over time, as these engines have been changed to be more, what they say is environmentally friendly. Then we've seen that change happen in the diesel mechanic shop, right, where there's somebody that didn't have to mess with sensors very often now has to be ready to handle those as well. So we have to be able to speak both of those languages, whether that's getting our fingers dirty on something that's mechanical, or if we have to know which buttons to push when to make something happen. So right now we have to cross train, and we have to do so at a very deep level. In the future, we may be able to divide those specialties out again, but for the moment, we got to be okay with somebody having to do both of those roles.
mm-hmm. I never will forget, I was at a gathering several years ago. It was a horse show, actually. And somebody's truck just sort of died, and happened to be one of the guys that was with us happened to be a diesel technician. And so they asked him, said, "Can you come take a look at this truck?" And he said, "Well, yeah, I can look at it." And he diagnosed or listened to the complaint, looked at the engine, and they asked him, said, "Well, can you pinpoint the problem?" And his response was, "Not without something that can talk to it."
Yeah, and you're right, Gary. And the thing too that you said earlier is that most farms have a technical specialist, and that's a problem. A lot of your dealerships have a technical specialist, and there's a lot more technology in the fields across North Carolina. And if you've got and many of them only have, the dealerships only have one technical specialist.
Yep.
That's an awful lot for one person to be able to handle. And that's one of the major complaints that we can hear is they just don't have enough trained individuals to go in there and do that type of work. So I think it is a critical need for sure in the future.
Okay, we'll move along here. Jason, you're up, but I'm sure I doubt any of you are farm lenders, but I'll still ask this question about funding available for farmers for upgrades or, increasing improving, upgrading their technologies or new type of equipment, particularly with this changing environment around there. What are you guys hearing?
That's something that I don't know that I have a very deep understanding of what kind of resources would be available for somebody to upgrade or to add, technology components to their farm. We have, there's some great, NRCS funding sources, that would be tied to, reducing environmental impact of some farming practices. And we can definitely, document how well we're doing and use that as part of an equip, package to try to submit that for funding and say, hey, we're doing buffer strips or we're doing wildlife management zones, and we're showing, how much of our land we're contributing to that and documenting practices that we're doing. But I don't know that many of the major resources that be available to directly pay you to make improvements, directly make technology improvements. So I definitely welcome any other input from our panelists here if they know of something. What we do see is a lot of times we have to pick the technologies that can give us the most direct return on investment the fastest. And so, whenever I think about what those are, the first one is auto steer, right? So if you do not have the ability for your tractor to auto steer, and you're looking to make an introductory investment into precision ag technologies, that becomes essential to success for the rest of the technologies that you may want to invest in the future. It would also allow you to farm in certain conditions where you wouldn't be able to otherwise. You can extend your hours and even reduce your stress a little bit because you can focus on what the implement is doing instead of holding a straight line, right? So it lets you think about the job you're actually doing instead of just driving a tractor. So, and that's why we see a lot of investment on planting, right? Because you only really get one chance to do it right. And so whenever people are thinking about investing in precision ag technologies, a lot of times they go to the planter to start with because it is the place where you can make or break a season if you do it wrong or right. So I would just, again, I don't know of any direct funding. I know that we can use technology to document good practices and try to use that to help us make good decisions. I also do know of sometimes if you're negotiating cash rents or going to a bank for a cash flow loan, being able to have historical yield data can help you with that process. It can raise the value of your land. Actually, we've seen this in the Midwest where if somebody had good yield data for a field for the last few years, 3 to 5 years, that their cash rents would go up if it's documented to be successful. I don't know how much of that we'll see in our region, but definitely something that we can be aware of in terms of, we can use the technology to drive land values or to help us get good cash flows whenever we need them during tight times.
Hey, Jason, you mentioned equip funds. I know that there's grant funding and some USDA equip funding, but it is kind of targeted under climate smart agriculture. So I think that might be some place that someone who's looking for some support could find it. But I think they're kind of hiding it under climate smart agriculture, but it would fit, I think.
Yeah.
That's
So
awesome.
maybe,
That's awesome.
if you could document some reduced tillage to try to allow, carbon accumulation in your soil, so if you're transitioning from a full tillage package over to a reduced tillage system, you may be able to go that way and maybe find some support through that. Yeah.
That's awesome. Time's running out, so I'm gonna ask one more question. Then I'll turn it back over to Trey for just general Q&A. I'm wondering about the small farmer. versus the large farmer. Advanced technique, can a small guy afford it? Are there specialty applications for small farmers that they can be competitive? Or is this such an expensive game that only the larger farms can play? Sandy, I guess it's your turn, Dr. Maddox.
Well, for me, I guess I don't see it, digital ag being something that is limited as much as it is affordable. Is it affordable to that particular entity is going to be the question. Even, you've got to weigh cost and benefits here. I think when you start looking at the scale of an operation, I think there's an opportunity for digital ag to be offered, and you've got plenty of things that small farmers could use that are really free options that give the grower basic insights into what's happening on their farm, whether it be weather apps, field management apps, that allow the grower to document all their field activities, to give them some insight. Those things can be free. But I think when you looking at precision planters and sprayers and those types of things, which we actually have, we have a small farm that we utilize those things on and are tracking our efficiencies to see what the cost benefit is. And there are we've had those specially made to meet our needs, which is even more expensive. So I think the opportunity is there. And I know as technology continues to improve and, autonomy gets more efficient, I think that those things that'll tip the balance a little bit more to make it more affordable. But I think it's more about what your limit is as far as how efficiency can make up for the cost of those non-free opportunities, sprayers and precision ag components. That's my take on it. And we do have some, like I said, some precision ag equipment on a very small farm. And we're tracking the differences to see what the timeline is for that. But Gary and Jason, y'all speak to it as well.
I think Sandy is absolutely correct. There are some of the farm management information system platforms, software, if you want to call it that. A lot of it is cloud-based now. But a lot of those you can start out for free. Now you have limited tools that you can take advantage of, but as far as getting a map of the farm, getting boundaries in there, knowing the layout of all the fields, downloading some of the soil data that's freely available, some of the satellite imagery that's freely available, those kinds of things, again, can be manipulated or used to advantage. As I said, I get some of the services that I sign up for. I get every day I get a rainfall report. And I would usually get a rainfall report. I had our family farm logged in on that. I get a rainfall report and I call my brother and say, I see you had so much rain yesterday. He said, well, yeah, how'd you know that? And usually it was accurate within a tenth or two as far, because he kept a rain gauge handy all the time. But again, the imagery, the rainfall data, some of the basic information like that is a good starting point. And that can be accessed in many cases for free or for a very minimal charge. And again, it requires a little bit of computer savviness, a little bit of computer access. But again, there are tools out there. Going on the more technical side, AutoSteer, we did a project several years ago on peanuts with automatic steering, and counting in the cost of the system and the correction and everything, the payback in peanuts was around 150 acres. It doesn't matter if it's 1 year, 2 years, or 3 years. The payback on peanuts, the break-even point was 150 acres. Just because by using automatic steering, we were able to increase the yield, an average of over 300 pounds an acre. And again, that starts to add up very quickly when you can tap into. And of course, that's an isolated case. Not every crop's going to have that kind of payback, but that was one example where it really worked to advantage.
Well, that's awesome. Okay, Trey, we're running out of time. Got a couple of questions, then you wrap us up, if you will. This is awesome discussion. Trey?
Yeah, we'll do one more question from the audience, and then we'll wrap up. And the question is, How is LiDAR being used to help more accurate mapping and navigation? Dr. Robertson, Dr. Ward, you guys want to take that one?
Well, I can start and Jason can certainly add a lot more than I can, but LiDAR is a technology that's being used to advantage throughout North Carolina. One of the things with some of the hurricanes we've had in past seasons, going back several years, is we realized we did not know with high degree of confidence where our floodplains were. And LiDAR data is helping us to improve that, because now we can tell you more accurately where flood prone zones are and do things to avoid that. From the agricultural perspective, LiDAR gives us excellent information on topography, and topography makes a huge difference in crop productivity. I remember going to a workshop several years ago up in Minnesota, actually, but the operator showed us a yield map and asked us to explain why he had yield variability. And of course, we threw out all the common answers and everything, fertility, soil type, and whatever, and he'd lay up a map showing that it didn't match. And finally, he showed us the map that almost matched the yield variability perfectly, and it was a topography map. And it was differences in elevation of a foot or so, made a huge differences in yield levels. So there's a lot of different uses for high accuracy data like that. Jason?
Yeah, I think you've hit it right on the head. We're actually really blessed here in North Carolina to have regular high volume LiDAR data available to us for free as taxpayers. The state is essentially broken up into 4 or 5 regions, and every year one of those regions gets flown with LiDAR data collected from manned aircrafts, and you can request that data from the state. Be careful, it is a lot of data, so you need to be ready to handle it and manage it appropriately. But especially whenever we're dealing with things like saltwater intrusion, drainage planning, being able to successfully grade and manage large topography, and even like the ones that you mentioned, Gary, these micro topographies in the field, being able to confirm drainage. So yeah, so we can get LiDAR from manned aircraft. We can get it from UAVs. It's not cheap in any platform, but it is getting cheaper. I saw that DJI, one of the drone manufacturers, is now selling a LiDAR equipped drone in the $20,000-$25,000 range. And you're probably thinking that's a lot of money. It is, but traditionally, UAV mounted LiDARs were in the 6-figure ranges. So now to have it even be sub $50,000 is actually really, really incredible, whenever they were running $160,000. So it's a tool we're using regularly. The data volume of it has caused me to avoid it sometimes, but it is a very useful tool that we can use. And also we can talk about landscape changes, right? Where are buildings going in? Where, how are the roads changing drainage, and how does that affect ag fields, and all those kinds of things. So it's definitely a tool that we are leveraging, and we're blessed to have a good public source of it, but we also can get local, very high resolution mapping with some technologies that are off the shelf.
Thank you. We are out of time. So I want to thank you, Dr. Robertson, Dr. Ward, Dr. Maddox, for some excellent discussion today on emerging tech and farming. I know I learned a lot today, and I did appreciate the little preview on blockchain technology and the application of supply chain and value chain, and verifying the origins of product, because we will have a webinar coming up on blockchain coming up on May 19th. So please keep a look out for some information on that, and maybe we'll have a couple of you guys back on for that one, talking about some of those value chain applications. So thank you all for joining today, and thank you for everyone who was able to attend today. I will send out a recording of this webinar next week on Monday with information on the speakers and any other information from their presentations today. So thank you all, and hope you have a great weekend.
Thank you.